you should be on page 184. We're still doing fractions. This time we're doing fraction addition and subtraction, but we're going to start with addition to warm up since we did that yesterday. If I'm adding fractions, if they already have the same common denominator, what do I do with that denominator?
Just leave it.
I keep it. That's why we had it in common, so we could keep it. Now, what do I do with my numerators? We add them together. So 1/4 and 2/4 is
3/4.
Okay. Now, next one. They don't have common denominators. So what's the easiest way for me to visualize and write them? Travois? Just how should I write them? How should I write them down?
Oh, with 4.
Now, I'm not asking for any numbers. If they don't have common denominators, what's the easiest way to visualize them and write them down? Tay?
You put the biggest denominator. You put the biggest denominator first.
I said I haven't asked for any numbers. No, you were right the first time. You said, oh, sorry. All right, it's when they don't have the same common denominator. It's easier if you stack them on top of each other up and down. That way you can put their, because you got to have equivalent fractions to be able, with common denominators, to be able to add them. And it's easier to stack them like this, then you can go right beside it to get its common denominator and equivalent fraction. Now, what number will go into 2 and 4? So let's just stop and think. Will 2 go into 2?
Yes.
Will 2 go into 4?
Yes.
So what's the common denominator?
4.
So I don't have to change this one, do I?
No.
What would I have to do to this 2 to get a 4? And if I had to do that to get that, I have to do it here. So this is 2/4. Now, what do I do with that denominator?
You just keep it the same.
I keep it because we already had it in common.
And then that's 3/4.
Okay.
Still.
So, are those kind of related?
Yes.
Okay, they're not the same. So we want to stack them so we can get their equivalent fraction right beside them. Will 2 go into 2?
Yes.
Will 2 go into 8?
Yes.
Yes, so what's the common denominator?
8.
8.
Why are you doing that?
So this one's already an 8, so I just keep it.
Times 4.
Okay, what would I do to 2 to get 8?
Times 4.
If I do it to this, I have to do it to this.
So it's 4 8.
And that makes sense. 4 eighths, 4 is half of 8. That makes sense that they're equal. I keep that common denominator,
And you add the top.
add the numerators, and that gives me
5 eighths. I didn't know how to do this yesterday, but now I know how to do it today because I'm paying attention.
well, that helps, doesn't it?
Yep. I had no clue how to do it.
So what I'm picking up is whatever the second number's denominator is the if it has a half, you use the 1/2 to add the half of that denominator.
What? I don't know. I didn't know either.
I got nothing of that.
All right.
Me neither.
Will 2 go into 2?
Yes.
Will 2 go into 6?
Yes.
So what's our common denominator?
6. At least you didn't say 2.
This one's already in 6th, so we just keep it. What would I have to do to this 2 to get a 6?
Times 4. I mean, no, not times 3.
Okay. If I do it to this, I have to do it to this. That makes sense. 3 is half of 6. That makes sense. We keep the common denominator. Good.
It's 4 6. 4 6. Easy. No, I know how to
Is that one in simplest form? The others have been. Is that one?
You
No.
can divide both of them by 2.
Okay, they're even, so I know I can divide both of them by 2.
And 4.
I get 4 divided by 2 is?
2. And then
6
third.
divided by 2 is?
3.
3. Is that in simplest form?
Yes. Because it has
Yes,
3.
because there's not a number that they will both go into evenly with no remainder.
But 3 is prime.
Because 3 is prime. Good. Prime means?
How
It doesn't have any
higher
factor.
than 2? Yeah.
It doesn't have anything you can multiply by other than itself.
Okay. There are no other factors other than 1 in itself. Is 7 prime?
Yes.
Yes. Is 8?
No.
No, because it has other factors. 2 and 4 are all 1, 8, 2, and 4. Are they all factors of 8?
Yes.
And if it has any more factors besides 1 in itself, what kind is it? Not prime, but
Composite.
composite. Good.
I never got prime until this year.
All right. Next one.
Why so many races?
On Monday.
And who's
On Monday morning, Diego ran 2/3 of a mile, and Priya ran 5/6 of a mile. Here is a graph a number line graph that represents how far Diego ran. Complete the diagram to represent how far Priya ran. Well, it told us that Diego, this is Diego, he ran how much?
2/3.
2/3. Now, when you're working out on a number line and then they gave you Priya's in sixths,
That would be
how can I get this number line divided up into sixths?
by 3.
Victor?
You can put a line between each tick because 1/6 is half of 1/3.
Okay.
But it isn't 3. Well, you can divide by 3.
How many, am I just going to have to put 1 tick? If I put 1 tick, then that would give me 2, 4, 6. So is that good?
Yeah.
That's what I need.
Like,
So I could do more ticks here. If this was 2/3, this tick they already had was how much?
2.
1/3.
The one they already had.
Oh, 1.
Okay. And then here's our 1. 1's equivalent to what in thirds?
3/3.
Okay. All right, but now we want to try to get it in sixths. So, we have 1, 2, 3, 4, 5, 6 sections. So this first one would be
1/6.
1/6. This is equal to
2/6.
2/6. So this one would be,
3/6.
and this one would be
5/6. And 6/6. 1 is 3.
okay. So now it's easier to see how far Priya ran. Where would this be Priya?
Yeah.
Yeah.
Because that's 5/6.
How much space is in between here?
1.
So that is 1 what?
6.
1/6. Now let's check it with what we know about.
Priya and Diego.
If we're going to be finding the difference that they ran,
You have to.
but we're gonna have to have a common denominator first.
subtract.
So let's look at Priya.
You put a D.
I know, because usually Diego's with Claire.
Oh wow.
You made it to go to that thing.
Okay.
You have to do it with the mouse. Or not.
Sometimes you do, sometimes you don't
That's
know.
stupid.
Okay.
Click on
Oh, okay. All right.
it. You're so mad.
So if we're going to do any kind of work with them, they have to be in the same denominator. So, will 3 go into 3 evenly?
Yes.
Will 3 go into 6 evenly?
Yes.
So our denominator's going to be,
6.
this one was already in 6, so we keep it. What would I have to do to that 3 to get a 6?
Times 2.
If I do it down here, I have to do it here.
4. 6.
Okay, and if we're finding the difference,
Subtract.
we subtract. So if we subtract, does the larger one need to be on top?
Yes.
Yes. So just switch them out.
Switch our rule.
Oh, minus.
Deja vu.
And we get 1/6, and that's what we said we should get when we looked at it on the number line.
How much farther did we ever explain or show your reason?
We just did that.
That's fun.
All right.
Subtracting and adding.
So now, instead of just adding, we're also going to be doing more subtraction. If you're adding or subtracting, it doesn't matter which one, you should stack them.
And you still got to have the same denominator.
Just make sure you pay attention to your signs. And yes, you still have to find common denominators. So it's easier to write them beside each other.
3/3.
6 can.
Will 3 go into 3?
Yes.
Will 3 go into 6?
Yes.
So our common denominator is?
6.
This one was already in 6.
And you
What would
got-
I have to do to this 3 to get a 6?
Times 2.
And if we do it here, we have to do it here.
2 6.
All right, we're subtracting, so we do what with that denominator?
You
Bring down.
bring down
Okay.
like common denominator.
We keep it, that's why we wanted it in common, and then we subtract our numerators. 4 minus 2.
2 6. Well, the answer is
If you didn't see that answer on ACT Aspire, what should you try to see if you can do to it?
simplify.
Simplify it. What number will go?
1/3.
Okay,
1/3.
he's already given me the answer.
Oh.
Is that right?
No.
No, I said 2.
You were giving up the answer.
Equals
Yeah, I know that's the answer.
1/3.
2 divided by 2 is 1, and 6 divided by 2 is 3. Is that in simplest form?
Yeah.
Yes, and I know it is for sure because what?
1.
It's got a 1 in it. Does a fraction have to have a 1 to be in simplest? No. Okay, we're subtracting, so we're going to stack. We're looking for equivalent fractions, so we're needing a common denominator. Always just look at your smallest one first. Will 3 go into 3?
Yes.
Will 3 go into 9?
Yes.
So our common denominator is?
9. Divided by 3.
This is already in ninth, so we just move it on over. What would I have to do to 3 to get 9?
Times 3.
So if I have to do it there, I have to do it here. So we would have
6.
6.
9.
What do we do with that 9?
Just bring it down. Keep your common denominator.
Keep it common, all right. 7 minus 6.
1.
Is that in simplest form?
Yes, because it has a 1.
No, because it doesn't.
Because it has a 1.
Getting a little bigger,
7.
but it's giving us a big one to add so that we can just practice that some more. Watch on your Aspire. Watch your signs very carefully. They may have one set, because how we usually do stuff, I give you either a whole bunch of subtraction ones or a whole bunch of adding ones all to get in the same little groups. They're not going to do that on Aspire. You may be adding on one, multiplying on the next one, subtracting on the next one, dividing on the next one, so be very careful.
Oh, now we're gonna do
Okay, when we're looking for that common denominator, of the two numbers you have, always just start with the smallest one. What, 8 go into 8?
Yes.
What, 8 go into 24?
Yes.
Yes, so our common denominator is,
24.
this one was already in 24th, so we keep it. What would I have to do to 8 to get 24? And if I do it to that one, I have to do it to this one.
21.
Oh my God.
Okay? We're adding. What do we do with that denominator? And then we're adding.
So that's 32.
What kind of fraction is that? Improper. Okay? So I need to turn it into a mixed, okay?
So that's the
24 will go into 32. How many whole times?
1. 2.
And then I got to see how much would be left over. Can't do that. So I have to borrow I just borrowed a multiple of 10 and I already had 2, so he'll be a 12 minus 4.
8. It's 8.
Okay. 8 what?
Yeah.
Is that in simplest form?
No.
No, they're both divisible by what?
4. 8.
8.
They're both divisible by 2. They're both divisible by 4. They're both divisible by 8.
Let's do it.
But if you don't know, if you don't see that larger number immediately, if I started with 2, would I eventually still get to the same number?
Yes.
Yes, I just have to whittle away at it a little bit longer. So they're both divisible by 8.
There's so many 1/3.
8 divided by 8,
Yeah.
24 divided by 8.
There's so many 1/3.
If I was making this as a, because you should already remember from this morning
Oh
what
yeah.
1/3 is.
33.
If I was writing that as a decimal, what would that be?
Point 33.
Okay.
Which is also 33.
What percent?
33.1%. Or yeah, that one.
What if I was writing it as a equivalent fraction to this?
33 over 100.
Okay.
Or 1/3.
All right. You jinxed me.
You jinxer.
It worked, and then it didn't work.
You
I just
jinxed.
stayed in here.
Okay. Now we're subtracting again.
Okay.
If we're subtracting fractions, we stack.
Could you just be quiet for a minute?
Shh, everybody. Okay, we need a common denominator. Always start with the smallest one, see if it goes into both. Will 4 go into 4?
Yes.
Will 4 go into 12?
Yes.
So what's our common denominator?
You better not say 4.
This one's already in 12, so we keep it.
Times.
What would I have to do to 4 to get
Times
12?
times 3.
And if I do it there, I have to do it here.
9.
And then you still
So I
subtract.
keep my common, and then I subtract.
5.
Is that in simplest form?
Yes.
Yes, there's not any number that will go evenly into both, or that I can divide both of them by and get no remainder.
It didn't work.
You still jinxed her, Jane.
It worked again. Stop jinxing her. No.
Jane, you actually sounded mad then.
Boy,
Yeah.
All right. Jada and Andre compare the growth of their plants. Jada's plant grew 1 1/3 inches since last week. Andre's plant grew 8/9 inches. How much more did Jada's plant grow? If we're trying to find out how much more, what are we trying to find?
The difference?
The difference, which means we're going to
Subtract.
subtract. Now I know that this one's going to go on top because I know it's larger because it has a whole number part. Good. So 1 1/3. Finding the difference. They don't have common denominators. Start with the smallest. Will 3 go into 3?
Yes.
Will 3 go into 9?
Yes.
Yes. So what's our denominator?
9. Better not do 3.
Now, this was already in ninths. What would I have to do to that 3 to get a 9?
Times 3.
So I would have to do it here also.
3 9. 1 and 3
Now, it doesn't change my whole number part, does it?
No.
Nope.
Okay.
Subtract.
So we keep that 9. Can I take 3 from 8?
No.
No, yes.
No.
Can I take 8? No.
You said it wrong.
No. I'm seeing if you're listening. Can I take 3 from 8?
No. Yes.
But that's not what I'm trying to do, is it?
No.
Can I take 8 from 3?
Yes.
No.
You made me say yes.
All right. So if I can't, I have to borrow just like always. But pay attention because this gets a little tricky. I'm borrowing a whole one. So he's going to now be a 0.
Wow.
How many ninths did I borrow if I borrowed a whole one?
9.
I borrowed 9 ninths. how many did I already have?
3.
3, so now I have
12.
12. Okay.
12.
Can I take 8 from 12?
Yes.
Yes. 12 minus 8?
4.
4. So how much more did Jada's plant grow?
4 9.
4/9 inches more.
Is this like one of the whole ones?
It didn't work.
Yes,
One of the whole on the cool down?
It worked.
definitely.
On the cool down?
Definitely.
No.
All right, see, Diego's usually with Claire. That's why I put a C in there to go. Diego and Claire compare the growth of their plants. Diego's plant grew 7/4 inches since last week. Claire's plant grew 9/8 inches. Whose plant grew more? How much more did it grow? Well,
Subtract.
first let's just figure out
8.
what they grew in the same denominator.
7. 9.
Okay, start with the smaller denominator. Will 4 go into 4?
Yes.
Yes. Will 4 go into 8?
Yes.
Yes, so my common denominator is
8. Why?
this is already in 8.
Times 2.
I would have to multiply that times 2 to get an 8, so I would have to do that here as well.
14. You have to do. Wait, what?
Okay,
So I get
now what do?
Subtract.
I subtract, okay, because we're finding the difference in how much they grew, so we're subtracting. What do I do with my denominator?
Keep it.
Keep it. 14 minus 9.
5.
Is that in simplest form?
Yes.
Yes.
Why you put
When I put what, babe?
why you put a 9 on?
Because yeah.
I have no idea,
I
because
thought.
I was looking at that 9.
Oh.
Good catch, Victor. All right, everybody makes mistakes. So 5/8. Now is it correct?
Yes.
All right.
It is 9/11.
All right, we're going to go take a bathroom break, and when we come back, you'll do your cool down. Bye.